to focus on the segments and angles, and more in particularly segment and angle addition. So we're going to be looking at parts and pieces. So this probably will feel intuitive and kind of natural, like, yeah, that makes sense. So let's talk about segment addition postulate. The segment addition postulate, it's a postulate because it's a math rule that works every single time. So in the math world, a rule or a process that works every time is called a postulate. So let's fill this in, and it will probably feel like, yeah, that makes sense. So what the segment addition postulate says, any two or more parts of a segment will always add to equal the total segment length. So any two or more parts of a segment have to always combine to be the total segment length. So pretty intuitive, pretty, like, yeah, that would make sense. So here we have a segment AC, and it's got two parts because point B can cut it into two pieces. So then we have segment AB and segment BC. If we put those together, it better equal the full segment length. So any two or more parts or pieces will always add to equal the whole segment. So then we're going to use that fact in a couple of different ways. First way, find DF. So we've got a segment, DF. It's got a point E in the middle, not in the middle, but in between them, breaking it into two pieces. So we just said that any two pieces will combine to be the whole, right? So to find DF, just add those two, and sure enough, 58. Good. Okay, find GH on the next one. Now this notation, where it's got these bars, that's just telling you that's the full length from F to H. So if you have the full length and a piece, Cameron, how could we find the length of GH? Good. Yeah, if you know the whole, you can take away one piece to find the other piece. What is 36 minus 21? 15. Okay, so it can work both ways. If you know two pieces, you can add them to equal the whole. If you know the whole, you can use the whole amount and subtract any piece to get the other piece. Okay, so then on this one, number one, we see the whole thing is 10. If the smaller portion from FE is 2, what's the length of ED? 8. Nothing too crazy. Okay, number two, we've got the whole thing being 14. From I to J is 7. What's H to I? 7. Now that's kind of a unique thing. Sometimes they will be the exact same amount, and then we'll talk about what that point will actually be. Now this one, there's nothing noted on there, so you'll want to put in the information they give you. So in your notes, do this. It says from J to L is 34, so I would just make a long bracket. From J to L is 34. From K to L is 19. And then we're going to find the length of JK. So Riley, tell me how you can find the length of JK. Good. Take the whole minus the piece, and how long is JK going to be? 15. Okay. So you may have to fill in some blanks on a diagram, and you may have to draw a diagram. And I highly suggest you do, because sometimes things aren't quite what you might feel like they are until you actually see it. So I would suggest drawing. Okay, so suppose that WX are points on the number line. So let's just create a number line. W and X, just put them on there, are points on the number line. If WX is 7 and W lies at 15, where could X be located? If there's more than one location, separate them with commas. So if W is at 15 and we know from WX is 7, could you figure out where X has to be? What would it be? 15 plus 7 is 22. And then I heard a different answer, because could X be over here? Yeah, it didn't tell us what side X is on. Yeah. That's why it says if there's more than one location, yes, there could be two different values of X, because it doesn't specify which side. this would still be 7, so if we go back 7, where would this x end up? 8, yeah. So there's your 2, and you would separate them with commas when you enter them in. So I do suggest creating a quick diagram just to kind of visualize what you're looking at. Okay, here we've got a segment RT with some pieces RS and ST. It says find the length of ST. So if S is at 4.3 and T is at 19.2, how could we figure out how the length of it is? Subtract them, yeah. You just subtract them. 19.2 minus 4.3 is going to tell you that difference. How long is ST? 14.9. Okay, how about TR though? We've got a negative over here. Let's think about lengths. If we're talking lengths, will it ever be negative? No, we're finding how far apart negative 8 and 19.2 are as a length. So you can do the same thing. You can still do 19.2 minus negative 8, but what happens when you minus the negative? It becomes add. So how long is TR? 27.2. Or you can think, okay, negative 8 is 8 away from the 0 and then 19.2 more to create that length. Since we're talking about actual measurements, they will not be negative. So keep that in mind when we're dealing with negatives. All right, so a second ago, we saw that sometimes the two pieces were exactly the same length, a 7 and a 7. So that point that's sitting in the middle ground of the segment, if it does create two equal pieces, we call that the midpoint. So you fill this in. Let me get my actual notes again. Okay, the midpoint. It is a point that divides your segment into two congruent or equal parts. That's what a midpoint will do. If it is actually truly right in the direct middle of your midpoint, of your segment, it will cut it in two congruent pieces, so it is called a midpoint. And it also can be called a bisector. A bisector cuts cuts one thing into two equal parts. Bisecting, you cut it into two equal parts. So in this diagram, what would be the midpoint? M. Good. So M is the midpoint of this one. These markings, the 2 and the 2, that they're the same, are indicating that they are truly exactly the same length. So if I knew from A to M is 10, what's M to be? 10. Yeah, that's what a midpoint will do. It will bisect, it will cut the segment right in half into two equal pieces. So we'll use that as well. Okay, this problem says find the location of K, which is going to be the midpoint of JL. So we got to figure out the middle ground of JL. There's several ways you can do this, but one thing you can do is figure out how far apart are JL. So we're going from negative 8 to positive 6. Is 14. So how many spaces should be on each side of the midpoint? 7. So then you could come back 1, 2, 3, 4, 5, 6, 7, and there it would be, and then just make sure 1, 2, 3, 4, 5, 6, 7. Sure enough, that would be the midpoint. So that would be where K is on negative 1. You could just do 6 minus 7 and get there, or negative 8 plus 7 and get there. Either way, whatever you want to do to get there is great. Any questions on that kind? Yeah, that, yes. Yep, add 1, divide by 2. Yes, for sure. That's perfect, and we'll be actually doing that in the future. Okay, point T is the midpoint of SB. So we know T is the midpoint of SB. So which side should S be on? The right or the left? The left. So it's got to be over here. We're supposed to find its location. So if T is the midpoint, what's got to be true about the length of TB and TX? They're the same. So how far apart are T and B? 13 from negative 9 to positive 4. Yes, there will be 13 spaces. So good. We got to be 13 this way. So yes, negative 9 minus 13 more. Where's that going to put us? Good. Negative 22. Good. Any questions on that kind? Okay. The figure below, G is between E and H. F is the midpoint. So let's just mark this as the same. If F is the midpoint of EG, we know for sure EF and FG are the same size. So if FG is 7, let's label it. And I really highly recommend you drawing these on your assignment today, so you for sure know what you're looking at. It only takes a second to draw it and fill it in. That way you won't make an error. And EH is 19. So let's just put a little bracket all the way from E to H, and that is 19. We are being asked to figure out the length of GH. So right here, we want to know how long is GH. What could we maybe do? Okay, good. So this is also 7, because we know that's the midpoint, cutting it in half. Good, so we have 14 in total. 19 minus 14, how long is GH? Yes. So if you just quickly draw a diagram and fill in the blanks with what they tell you, it makes it a little bit more clear than trying to just visualize it in your brain. Okay, now, angles have the same type of a property. There's an angle addition property, which says almost the same thing. So let's fill this in. Any 2 or more parts of an angle will always add to equal the whole angle. Same thing. It'll create 2 or more parts can be added to create the whole angle. So in this particular diagram, we've got one big angle, angle ABD, and then 2 smaller angles. Now, let's talk about naming our angles so we know what we're talking about. There's 2 ways you can name an angle. If it does have a number in it, you can use the number. This would be angle 1, this would be angle 2. If it doesn't have a number, you do need to use all 3 letters that create the angle, but the vertex has to go in the middle. So if I want to name the big one, I name it ABD or DBA. The vertex has to go in the middle. So let's just write a little equation that's showing the 2 parts equal the whole. When you name an angle, you actually use this little, angle symbol. So do this with me. It kind of looks like a less than. But it's saying angle, and we can say angle 1 because this little guy has a 1 in it, plus angle 2 equals the big angle. We have to use all 3 letters because it doesn't have a number representing it. So we would say angle ABD or DBA. You can do either or. But that's how you name an angle. You have to use all 3 letters with the vertex in the middle, or if they give you a number, even better, you can use the number. So that's what the angle addition postulate is telling us. Any 2 or more angles can add up to equal the whole. And we'll use it similar to like we did on the segments. So in this figure, it says the measure of angle ABD, so that's the whole thing, is 142. Let's just set it on the outside so we're clear. And angle 2 is 98 degrees. We put 98 degrees in angle 2. We have to find angle 1. Madeline, how could we find angle 1? Yeah, same thing. Take the whole minus the part. It's going to give you the other piece. How big is angle 1? 44 degrees. Yeah, try to get in the habit of putting degrees on these angles. That's what they're measured in every time. Okay, now let's talk about the bisector. Just like the segment had a midpoint that bisects it, an angle can also have a bisector that cuts it in half. Jace, you with me? But the bisector, if you write this in, it's going to be a ray. Remember, an endpoint to an arrow. A ray that is exactly in the middle of your angle will bisect it. And same thing, if it's going to bisect it, let me get my right word in here. The bisector is going to divide that angle into 2 exact same pieces. The bisector will divide the angle into 2 equal or congruent pieces. Both angles will equal each other. The pieces will equal each other. So just like the segment bisector, an angle bisector will do the same thing. It will cut it into 2 exact same pieces. For example, this one, ray YW is bisecting angle XYZ. So angle 1 and angle 2 are equal. You just write that. Angle 1 equals angle 2 if Y W is the bisector. So let's use that. Here we've got ray QS. So ray QS bisects angle PQR. The measure of angle PQS is 24. So what's the measure of angle PQR? 48. Yeah, they're telling me angle PQS. So you've got to follow PQS is 24. So what's the measure of SQR? 24 as well. So if they want to know the measure of the whole thing, PQR, what's the measure of the whole thing? 48. Any two pieces will add to create the whole, and if you have a bisector, those two pieces are exactly the same. Everybody okay with that one? Okay. Now this one, again, I do highly recommend drawing the examples and just filling stuff in so you know for sure what you're looking at. We've got the measure of JKM. So from J to K to M, we got the whole thing. It's 98. And I just like to set it on the outside so we can fill stuff inside. Then the measure of NKM, so follow N to K to M, is 32 degrees. So put a 32 in there. KN bisects angle LKM. So what do we automatically know? LKN is also 32. Good. The KN is the bisector of LKM. That's also 32. And we have to find JKL. So darken it or something. Darken J to K to L. That's the one we're trying to find. So can we find it? Yeah.
34.
Good. We got how much right here? 64. So the total is 98. If we do 98 minus 64, what's the other missing piece? Yes. Any questions on that one? Okay, next one in the figure, and measure of angle JKM. So again, the whole thing is 80 degrees. I will put that out there. The measure of LKM, L to K to M, this whole thing from L to K to M is 46. So all of this is 46, L to K to M. KN bisects LKM. So what is that going to tell me about these two individual pieces? They're the same, and they're 23. Good. Got my degree. 23 is all right. Find JKN. We got to know what we're finding from J to K to N. All of that. All of that. So it's these two together. We got to figure out this one. Good. So 80 minus 46 is how much? 34 right there. So these two together, 34 and 23, is 57 degrees. So it actually really helps if you just quickly draw it, fill things in, darken the angles you're looking at so you're not confusing yourself. Any questions about segments or angle bisectors and addition? Okay. All right, so we have the rest of the time, which is 25 minutes. So we should be able to get close to, if not finished. And so grab a sheet of paper. Let's call this segment and angle addition. We'll take another look at this on Monday with a little more in depth. Give me your first and last name. Today is the 21st. 7th. So you'll be, for your work, you're going to be showing like adding the two pieces to get the whole or subtracting the whole.